Hello everyone, this is Yingxue. My final project's topic is object classification, focused on flower classification. The goal of my project is to classify flower pictures by 5 different categories. I used fine-tuning method and retrained on an existing model. Then once I finished retrained the model, I uploaded some new test images to see the model performance. And the model can tell me what kind of flower is it. So in our class, we have spent some time on classifying cats and dogs pictures. So actually, image classification is one of the biggest topic of deep learning, and transfer learning is the very popular method in image classification problem because they allow us to start from the model that have been trained before. So we don't have to start from scratch and train a model, train a huge model by ourselves. I'm using MacBook and this is the hardware environment. For the project, I used Google Collaboratory and connected with Google GPU for the entire training process since it's very computational expensive. The method I used is fine-tuning, as I mentioned before, and the model I started is the Inception V3 model, which has been pre-trained by Google Brain Team, and similar like VGG16 that we have learned in our class, it's also available as part of Keras application. And I installed some packages like Keras, Matplotlib, Inception v3, NumPy, and PRL, etc. Those are the steps that I took. I downloaded a relatively smaller dataset from Kaggle, and I split the raw datasets into 2 groups, which are training datasets and the validation datasets. Then I mounted the Google Drive with Google Collaboratory. So I start the coding and install some packages that I will need later. Then set up the image size and load the existing Inception v3 model. And finally, I plotted the training and validation accuracy once I finish training. Then upload some test images to see the model's performance. Here is a overview of my datasets. So I have 5 images for each category in the training set, so total is 2,500 images, and 100 images for each class in the validation datasets. So I have 5 categories here. The model that I retrained is Inception v3, so here is a little background of Inception v3 model. Similar like VGG16 and MobileNet, those are based on the ImageNet challenge. So Google reviewed the Inception v3 model, I think 2 years or 3 years ago. And it's a widely used image recognition model or the very popular image classifier, which has a very good accuracy and performance. The transfer learning and fine-tuning can allow us to retrain the final layers of this existing Inception v3 model and apply it to my much smaller datasets without extensive training and computational power. So here are 3 basic strategies of fine-tuning. They are train the entire model, or you can train some layers and leave the others frozen, and then or you can freeze the convolutional base layers and then retrain the model. So here is a overview of my code. This is the training and the validation accuracy. So finally, the model reached about 85% accuracy. And here is the test results, so I can show you here. Here is I after training I saved the model in my Google Drive, and here is the first test pictures, which is almost 100%. It's 100% sure that it's Daisy. Then I try to use a different color of Daisy. Then it tells me that it looks like sunflowers as well. This is dandelion, and it tells me there's a little bit daisy as well, maybe because of this part. And this is rose, and the shape maybe looks like tulips as well. So, and here is a pur purple rose. Then sunflowers, 100% sure. Different color sunflowers. Looks like daisy as well. The 100% sure for tulips. And another tulips. So it looks like the model performance is pretty well. The lessons that I've learned is I've learned a lot from the final project as well as when I got some error message. So before I started working on this final project, I did a lot of research, and um, I I see a lot of people doing similar research project and training the model by using different learning rates, and they reach um, they reach very good results. And when I train the model, I got first of all, I did not get very good performance because in the lecture notes that we have, we trained on the cats and dogs, which we use the binary um, as a class mode. But for my project, I have 5 classes. So when I realized that I made that mistake, I changed it to the categorical because I have more than 2 classes. So after I retrain the model, and the performance are better than the first time. So this is my final project. If you're interested, feel free to download my model. Thank you.